So I wrote out some examples for you. First example, f of x equals the set of ordered pairs x, y, such that y equals plus or minus square root of x. And the question is this a function or not? Well, the pair 4, 2 and the pair 4, negative 2 are both in f. Try them. If you put 4 in for x, y can be either 2 or negative 2, plus or minus square root of 4, right? So those two are both in f, and so f is not a function. So y equals plus or minus square root of x is not a function. Second example, G is the set of all ordered pairs x, y such that y equals x squared. This is a function. Because if you plug in any number for x, you'll get exactly one number out for y. So every number in the domain is paired with exactly one number in the range. Remember, the domain here is the values of x, and the range is the values of y. Okay, so each value of x is paired with exactly one value of y, right? If you put in 2 for x, you get 4 for y. One thing out. If you plug in 3 for x, then you get 9 for y. Just one number. You don't get two different y's for 3, right? Etc. So that one is a function. So usually, this is using set builder notation, example 1 and 2. Usually we would just write the formulas for them. F of x equals plus or minus square root of x, and g of x equals x squared. Means the same thing, okay? I just want you to get used to seeing both ways, because you will be seeing them both ways and you have to understand what it means. So here, example number 3, I just graphed something. And I'm asking you, is that a function? And hopefully you will say, no, it's not a function. Why? Because I can find a value of x that gives me two different values for y. So like, pick an x here, pick this x. Well, there's 2 points with that x, that value of x, right? Which means that value of x occurs twice, which means it's not a function. Or if you want to think about it this way, this one here gives you a y value here. If I go up to the second one, it gives me a y value here. So the first, this coordinate, x coordinate, is being paired with two different y coordinates. So it's not a function. Now on this last one, what I did is I just took this and I just turned it around and put it down here. Okay, so now if you think of any x value corresponds to exactly one y value. So if I had this x, then the y would have to be here. If I had this x, the y would have to be here, right? And if I had this x, the y would still be here, etc. So each x gives me exactly one y. Each value of x gives me one value of y. So that second one is a function, or example 4 is a function.